Okay, so we're going through chapter 1, section 1 now, and you have access to this student handout, and you can either fill it out through Microsoft Word, or if you have access to a printer and you like to print things out and walk through that. So check out these student outlines that are available for you, and either reading the textbook, watching these lectures, you'll be able to fill in these student handouts as we go. As a statistics overview, you might have already read in your textbook, if you're looking through for chapter 1, section 1, there's a lot of definitions here, but hopefully this is getting you excited about statistics because there are so many applications for this course that you'll end up hopefully using later on in whatever career you go into. So conducting statistical studies, we're going to break it down, and the way the author does it of your textbook is in prepare, analyze, and conclude. Just know this is kind of the setup, prepare, analyze, conclude. And as we actually do these, it'll make more sense as we go. Statistics, it requires critical thinking, the ability to make sense of results, and going beyond the mere execution of complex calculations. There are some calculations, but make sure you're stepping back with statistics and thinking, does this make sense? Because with statistics, we're looking at a bunch of numbers, we're trying to make sense of it. So rather than getting stuck in the calculations always, try to step back and question, does this make sense? Are we asking the right questions to make it make sense? So to define data, and you'll notice in your student outline too, data is the plural form. Okay, so you say data are, when we're talking about data. So data are collections of observations, whether it be measurements taken, hair color, survey responses. We'll get way more into just going beyond the definition, but it's collections of observations. Data are collections of observations. Statistics, another definition, science of planning, studies, and experiments, obtaining data, organizing, summarizing, presenting, analyzing, and interpreting those data, right? Data being a plural word, then drawing conclusions based on all of that above. Again, going beyond definitions as we start to practice, I think is what you should focus on, but just want to introduce you to these definitions as well. Another definition here, population. It's a complete collection of all measurements or data that are being considered. So typically the complete collection of data we would like to make inferences about. And then we have two categories, census versus sample. So a census is a collection of data from every member of a population. And that comes with kind of a caveat. Can you get data from every member of a population? Well, it depends on what population you're trying to probe. And then a sample is a sub-collection of members from that selected population. Okay, and when you're collecting a sample from an entire population, you have to be careful about what that sample is representing. Is it representing the whole population? So rather than like we're just focusing on calculations, we need to think through things like this. Are we collecting data that's going to be accurate and fair? And will the conclusions make sense? Okay, so here's an example. So in a journal article in a reputable publication, it was stated there are 38 million carbon monoxide detectors installed in the entire US. Okay, so when 30 of these 38 million detectors were randomly selected and tested, it was found that 12 of them failed to provide an alarm in hazardous carbon monoxide conditions. So here we need to think about what is our population, what is our sample, and another tip with these videos, if you ever want to pause and try to think through the answer, highly recommend doing that and then pressing play and listening. Okay, so if we're considering the population here, it's all 38 million carbon monoxide detectors in the US, right? That's our population. The select sample that we're taking, because it would be hard to collect data on 38 million different devices. Right, so our sample here is 30 of those 38 million that were actually selected and tested. Okay, and then we can think about an objective here. So this is how we think of populations and samples. So to use sample data as a basis for drawing conclusions about the population as a whole, okay, of all the carbon monoxide detectors. And then methods of statistics are helpful in drawing such conclusions. So again, we need to think through critically, are we randomly selecting 30 from that 38 million? Do we happen to be selecting 30 that were all purchased in the year 2020? Are we selecting 30 that are all from owners in the state of California? So we need to make sure that the sample that we're picking is truly representative of our whole population. Okay, so again, you'll start to memorize this just by seeing it so many times because of how the author likes to set it up. So we have our prepare, analyze, and conclude. Okay, so again with prepare, I'm gonna be saying a lot of things, and as we actually practice, that's what will be the most important, but at least I wanna introduce you here. So in prepare, we think of the context, the source of data, and the sampling method. Context, what do the data represent? What's the goal of the study? Source of data, so are the data taken from a source with any special interest so that there's pressure to obtain results that are favorable to that source? Maybe pause and take a moment and think of an example. One thing that comes to mind is different election polls, and so you have to keep in mind the source who's taking that poll. Sampling methods, where the data collected in a way that's unbiased or biased, such as, so a bias would be such as a procedure in which the respondents volunteer to participate, right? So if somebody surveys you and they want to know if you're interested in soccer, for example, if you already are interested in soccer, you might have a higher chance of even responding to that survey to begin with, and you're volunteering to respond. Okay, analyze, we're gonna think of how we can graph the data. We'll talk a lot more about graphing. Explore the data, so we can look for outliers. As the name implies, an outlier is a number that's very different, is further away from the other data. Important summarizing statistics, a mean and a standard deviation. You may have seen that before in one of your math classes. How are the data distributed? We'll talk more about Gaussian curves and data distribution. Are there any missing data points, or did any subjects refuse to respond? So again, going beyond just the classic math equations for statistics and really keeping your critical thinking cap on. Did the data make sense? Why or why not? And then for apply statistical methods, and there's different ways of doing that. We'll use Excel, for example, as a way to calculate numbers. And then concluding, so do the results have statistical significance, practical significance? Again, there's data for almost every subject area: sociology, finance, chemistry, biology, environmental science, even the fires in California. So collecting data and really thinking, does it have statistical significance that is worth bringing forward to apply for grant money, things like that. So again, you're learning this and it applies to so many different fields. And we'll practice all these three categories. So here's one example. And now we're in the prepare side of it, right? And so to remind you about the prepare, we have context, source of data, and sampling method. There's pleasure boats, so boats that people ride not to ship material somewhere, but they own a personal boat, for example. And so on the top, we have pleasure boats in the tens of thousands. And then we have manatee fatalities. Okay, so if we have this data, so we have pleasure boats and manatee fatalities, can we see any correlations? Is this biased? We can think through these different statistical principles and reasoning as we're looking at a data set like this. Okay, so again, we're in prepare. So you have context, source of data, sampling method. So an example of, we see this data and now we're in the context. So the data representation and the goal of the study is what we're looking at when we're in prepare and then in context, right? So those, we have prepare and then we're in the left-hand side for context. So the table includes the number of registered pleasure boats in Florida by the tens of thousands and the number of manatee fatalities from encounters with boats in Florida for each of the several recent years. So we don't have the recent years data, but this is the context of the data. The format of the table, it suggests the following goal. So even just how the table is formatted is something we can think about. The goal here is to determine whether there is a relationship between the numbers of boats and the numbers of manatee deaths from boats. Okay, so we're trying to make a correlation here, and we can tell that's one of the goals based on how this table is set up. This is all still part of the context. And again, we're still in the prepare section. So the source of data, We want to think, is there any special interest that was involved in how we even have this data in front of us? So the data is in the table. It's from the Florida Department of Highway Safety and Motor Vehicles and the Florida Marine Research Institute. Okay, so those appear to be reasonable and reputable. So we should ideally trust data like this, but of course, you can't guarantee that necessarily, but if it's some governmental source, ideally it's something we can trust. So versus like a magazine, for example, or the Manatee Protection Society Against Boats, for example, if that was an organization and they presented this data, we might want to question how they got the data. The sampling method, is it biased? Is it unbiased? Do the respondents have to volunteer, or is everyone required to answer? So the data were obtained from official government records known to be reliable. Okay, so the sampling method here appears to be sound and trustworthy. One more part of this, we're still in prepare. So voluntary response sample, or a self-selected sample. So defined as one which the respondents themselves decide whether to be included. So if the respondents are deciding if they want to be included in the survey, that type of sampling is flawed, right? So I can decide personally if I want that data point from when I was riding a pleasure boat and something happened to a manatee, which is just a hypothetical scenario. If I decided I don't want that data point to be included, then this is an example of a flawed sampling method where I can volunteer that information. So we shouldn't make conclusions about a population based on samples with a strong possibility of this bias. So again, the bias is from the fact that I can volunteer whether or not to let that data point be used in statistical methods. Okay, so the top part of this slide and part here are from a previous slide. Below that, I'm providing additional examples of what could be bias. So for example, internet polls where people online can decide whether to respond. Again, that's not going to be a completely unbiased set of data if it's coming from an internet poll where do I want to reply or not? If there's that flexibility or that freedom, then it's an example of a biased sampling method. Mail-in polls, that's also an example of something that is biased, so where people can decide whether to reply or not. It's not taking data points from your whole population or even an accurate small sample of a population, because I can decide whether or not I even want to send in my response. Telephone call-in polls, where newspaper, radio, TV announcements ask you to voluntarily call in and let them know about your opinion. Not always, but occasionally if somebody is more opinionated, either strongly or against something, they might feel more like they want to call in and voice what they have to say. So these are all examples of biased samples or sampling methods. Try to think of some more related to maybe your area of interest. Here's more on these voluntary responses. Let's say Nightline asks viewers to call in with their opinion about whether the UN headquarters should remain in the US. The United Nations headquarters, if you didn't know, it's in Manhattan, New York, it's in the US. Okay, so viewers then decided themselves whether to call in with their opinions. Okay, so I'm deciding whether or not I want to call in. And so that's what everyone else is doing who's watching Nightline at the time. So 67% of 186,000 respondents said that the UN should be moved out of the US. Okay. In a separate independent survey, 500 respondents were randomly selected and surveyed, and now 38% of this group wanted the UN to move out of the United States. It is really, really important to know that something that's voluntary based is going to be biased. Okay. Okay, so again, we see these two polls have very different results, right? So in the poll that involved 186,000 volunteer respondents, that's quite a large sample of the population if the population is supposed to represent the entire US, the entire world. So it's a lot of respondents, but the smaller poll of 500, and here's the key part here, of randomly selected respondents is more likely to provide better results because of this superior sampling method. Okay, so voluntary is biased, randomly selected has an opportunity to be much less biased. Okay, again, I'm coming back to this prepare, analyze, conclude, and so far we've looked at prepare quite a bit. Okay, now on the analyze portion of these 3 steps that the author likes to use. So in the prepare step, we considered content, the source, the sampling method. Voluntary is biased. A random sampling can be unbiased. Okay. And then in the analyze step, we have graph and explore. So an analysis should begin with appropriate graphs and explorations of the data. We'll talk more about graphs, but they can be extremely misleading depending on how you set up the X and Y axes, for example, and depending on the type of graph that you're choosing to represent your data. Applying statistical methods. So a good statistical analysis does not necessarily require complex computational methods. Sometimes it can, but a good statistical analysis does require using, again, common sense to carefully pay attention to what are we trying to do ultimately? Where do we get this data from? What do we want to prove? Or what do we want to not prove? Do we have special interests in mind because we want to prove something? So all these sort of critical thinking, you want to be completely unbiased as somebody that's calculating statistics, okay? Because you don't want to end up doing a calculation in a way that benefits you personally. Okay, now we're in the conclude portion. So in the conclusion step, develop an ability to distinguish between statistical and practical significance. And it can be a little, the line can be a little blurred here, but statistical significance is achieved in a study if the likelihood of an event occurring by chance is 5% or less. Okay, and we'll talk more about this, but for example, if we have 100 random births, if 98 girls are born out of 100, that is statistically significant. So not just in theory what happens, but if we have 100 random births and 98 girls are birthed out of those 100 families, then this is statistically significant because such an extreme outcome is not likely to result by just random chance. Okay, so that 5%, we'll talk more about how we can actually figure out if it's 5% or less mathematically. This is just to introduce you to the concept of statistical versus practical significance. If 52 girls are born out of 100, this is not statistically significant because that event could easily occur just randomly. Okay, so we'll talk more about the math here involved, but just kind of get used to thinking of, is it statistically significant? Is it not? Is it just practically significant? Again, it is statistically significant if in a study, if the likelihood of an event occurring by chance is so low. So would that happen normally that 98 out of 100 girls are born and only 2 boys out of 100 were born as their assigned gender? That's pretty extreme, right? So that is statistically significant. However, 52 out of 100, okay, that makes sense just by chance. Okay, so practical significance, more on this to differentiate definition-wise. It's possible that some treatment or finding is effective, but common sense, so we'll talk more about treatments too, but common sense might suggest that the treatment or the finding here does not make enough of a difference to justify its use or to be practical. Read that a few times. So if something has practical significance, it's possible that some finding, so here we found that 52 out of 100 girls were born, for example. It makes common sense that this finding is similar to what you'd experience or what families would experience just by pure chance. Okay, so kind of the key here between statistical versus practical significance is to think, does it make sense practically for this to happen at random? So again, 98 girls out of 100, that by random chance, that probably wouldn't happen. So that is statistically significant. 52 girls born out of 100, could that happen just randomly? Yes, right? So about 50-50. And one thing to think about here when we talk about these treatments or findings is if, for example, what this means in this context, let's say that a family was really wanted a girl. Okay, so if they read that, if you take an hour-long walk at 8 a.m. every morning, you're more likely to have a girl if you do that during your first trimester, for example. So if that is what the families think they can do to have a girl, and then truly 98 girls are born out of 100, that has statistical significance, okay? If the women do a walk at 8 a.m. every morning, but then all 100 women do that, and it turns out 52% families had girls anyway, then is doing the walk worth it? Does that really show that that is going to lead to you having a girl? No. Think about this a little bit and try to differentiate really well in your mind statistical versus practical significance. Okay. Okay, so now we're going to talk about a few pitfalls that come with analyzing data. Again, I realize these are a lot of definitions and a lot of text, and we'll end up practicing these more. Okay, so misleading conclusions is one example. So when forming a conclusion based on statistical analysis, we should make statements that are clear even to those who have no understanding of statistics and its terminology. Okay, so if we are reporting and we're the statisticians and we're using phrases like in the Gaussian curve, on the left-hand side of the Gaussian curve, when the p-value was a certain p-value, we ended up with this result. That's not helping the population understand the result of our statistical analysis. So we want to make the analysis easily digestible for everyone. Another example of a potential pitfall, sample data reported instead of measured. So when collecting data from people, it's better to take measurements yourself as we're collecting data versus asking a subject to report on their results. Again, if we're going back to the birth example, if we asked the families, was the woman who's pregnant, was she really taking a walk at 8 a.m. Every morning, an hour-long walk? If we're counting on others to report that information, yes, no, it's not going to be as accurate, of course, as if we saw that take place and we're measuring it on our own. Loaded question, so sounds like what it is. So if a survey results are not worded carefully, the results of a study can be misleading. The example in your student handout does a nice job at this, so go ahead and read that as an example of loaded question. So it really depends on how you say it. Should we have classes online because it's a lot safer if we do that? It's like being like, right, should we have classes online because it's a lot safer, right? I'm kind of leading you into answering, yes, of course we should have classes online. Okay, this is more pitfalls. So order of questions, you took the student survey, for example, and if I had put, something as question number 1 versus something as question number 2, 3, or 4, it all matters because you're usually reading in order, question 1, 2, 3, 4, 5. So considering the order that you're asking different questions can play a big role in the outcomes. Non-response, so this occurs when someone either refuses to respond or is unavailable. Of course, that's going to impact your data at the end. Percentages, so some studies cite misleading percentages. So note that 100% of some quantity is all of it, right? If we have 100%, that's all of it. But if there are references made to percentages that exceed 100%, obviously that's not justified. So we know that in theory, if something happens mathematically, a really easy check that we did something wrong is if our percentages add up to 105%, because we know that can't be the case. Okay, so that is the end of chapter 1.1. Typically with these, so you have your student outline, you've read through it, you've read the textbook, you're starting to do practice problems on MyStatLab and do your homework problems. Again, let me know if I can clarify anything. Again, really make this semester yours. I am just, again, an email away. Really use that to your advantage, and I will talk to you all soon over email or in office hours, and then look for the next lecture recording that will be available to you. Hope you're all doing well, and I will talk to you all very soon.